So I'm Francis Lau. I'm from Smartsheet. Just a quick show of hands who have heard about Smartsheet before. 1, 2, 3, 4, 5, 6. That's more than I expected. I'm Francis Lau. I'm the Senior Director of Product Intelligence at Smartsheet. Today we'll cover a little bit about the company as well. And I have here Bill Landers. So if you guys, any of you ask me difficult questions, I'll have him answer it. So today's agenda, so great coverage on Kinesis and then on Databricks. We're going to walk through our experience with the platform, with these two products and actually a couple more products as well, AWS. So I'm going to go actually 20,000 feet level and then all the way down to actually looking at some code, right? I started as an engineer. I got to show some code whenever. So we're going to talk about Smartsheet, about what we do and our application. They'll give you a little bit about context about what we're doing with the data, right? And how we use it. And then we're going to talk about our experience, what we did in our proof of concept. We ran a proof of concept for 9 weeks, and that happened about 3 months ago. And from there, we actually learned a lot about Kinesis, Databricks, Lambda, Redshift, and so on and so forth. So then I'll kind of cover all our learnings in that in the POC, and then we'll actually show you some specific code things that we learned about. Okay, about Smartsheet. So Smartsheet, we are an online app for unstructured, self-directed, collaborative work. Many people, when they hear the name Smartsheet, they think about, oh, is it a Google Sheet or Excel spreadsheet competitor? It is not. It is a, I'll show you in a minute, it is, the word sheet came from, it is actually an application that has a spreadsheet-like UI. But from there, we provide a lot of different capabilities beyond it. So, we have about 70,000 organizations as customers and millions of users in over 175 countries. 250 employees in Bellevue. We're in Bellevue Place, right across from Bellevue Square. Entire company is actually in Bellevue, so it's great. The company has been growing 80% year over year for the past 5 years, so really fast growth. I've been with the company for 6 months. When I started, it was 180 people, right? And we're like 250 right now. So we have new employee comes in every Monday, and they come around for a tour, and there's always like 5 to 10 people coming through every week. So it's a great place to work. One interesting thing about our product is it is very flexible. So it's used by many different companies, from tech companies to government agencies to mom and pop shops, right? For example, it's used to coordinate a lot of different events like the Final Four, Super Bowl. The Mayweather fight was coordinated using our application. And then it's also used by some mom and pop shop. There's a sign builder that actually use our application. We have even heard of a case where a mom actually planned a wedding for the daughter using our application. So very diverse use. I'm going to show you real quick on on our application. So it's a very familiar spreadsheet UI. What we found was that many people use, Excel is great, right, to calculate stuff. There was the original intent of it. But really, people use Excel or Google Sheets for many different purposes, maintaining lists, communicating, and so on and so forth. So what we did was with that UI, we took 20% of the mostly used features of spreadsheet, project management, file sharing, and collaboration, and put it into one application. And it's very flexible. It works the way you want to, and it's very simple and powerful. In fact, our biggest struggle is it's such a simple UI. People look at it, they don't know where to start because it's ultimately so flexible. So I'll show you real quick our application, give you a sense of the data we collect. So here's our UI, spreadsheet-like interface. One of our colleagues actually built a checkers game here. So Bill and I actually were playing checkers in the office. When I make a move, he'll get notified. When he makes a move, I get notified, right? This is not custom code, right? Actually, just using our features. So just to give you a sense of the data that we collect and how it's used for collaboration, I'll just show you some of the sheets you can create. So for example, if you can create a project sheet. And what you see here is a very familiar, looks like Microsoft project, right? Task name, start date, end date. And you can have a Gantt chart here on the right. You can pivot over to a calendar view. Very familiar. Okay. I can do something simpler, like a task list. And it has a task name, due date, done, assigned to, comments. Right? These are just templates that we created. You can actually create a blank sheet. And now this is where people go like, okay, now what are all the really cool things you can do with it? You can actually go in and specify a column. You can go name. You can say, you can give it a data type, complete it, and make it a checkbox. And then now you can actually have a task, and you can make it completed. You can then give it you can even make it symbols, right? Kind of regular RGB type thing, and say risk, and you can come in and now pick different symbols, right? It's very flexible. You can indent and outdent items. You can have hierarchy. You can actually, in the collaboration sense, set of features, you can actually start discussions on a role and start to have discussions on a specific role of information. If I want to ask Danny for an update on this task, I can right-click and say, send update request. In this case, I'll ask Bill, because please update. Where is my drink? And he'll get it on his phone, or in his email, he can click on it and then reply to it. So really, if you can look at all that set of information, it is like a spreadsheet, like a Microsoft project. You can actually do file sharing. You can attach files at the row level, right? And attach different files to it so that you can, and all the files are versioned as you checked in. So it's got really 20% of the features you use across Dropbox, Microsoft Project, Google Sheets, and any kind of collaboration software. And the interesting thing about this is because it's so flexible, and we have customers using it across many departments and across the world, we have a diverse use cases and customer set. So one of the biggest challenges is trying to really figure out what our customers are doing. One of our biggest customers is a tech company, so have 30,000 people using this application across the world. And it grew virally. We didn't have a sales team for the longest time. It is one user using it, and then they share a sheet, and then it started growing virally within the application. In fact, in that 30,000 user company, that was how it started. So then when it got bigger and bigger and bigger, and people, and then obviously they bought more and more licenses, then the CTO or CIO will go like, hey, we have 5,000 people using this application in our organization. What are they using it for, right? And that is where we start, and because data privacy, we can't look at the data they use. We started digging into using kind of data science and big data processing to really understand how, even for a specific company, what are people doing? How are they collaborating? How are projects completed? Where are all the energy spent in completing tasks? How do they align with the corporate goals, right? Because in today's day and age, in information worker age, the work that is done is very bottoms up. It is unstructured. It is self-directed, right? It's much less so where in a construction project you lay out a Gantt chart and you are very structured. You tell people what to do and you work down. So that is more of a top-down. So in this world, it is very bottoms up. So even within companies, we have customers who go like, hey, we see a lot of usage here. People love your product, but what are they doing? So I'll segue then into some of the, how we use the data. I'll just show you a couple of demo apps that we have. So very basic, a dashboard, right? So here's just a demo dashboard that shows what users are doing for a specific account. What are they doing in terms of collaborating? How many active licensed users are there? What are the top users? And what are they doing? Are they sharing? Are they creating? Are they creating reports? Are they importing sheets? So on and so forth. When are they most active? What countries are they active in, right? So just, and then here's trend data as well. So we use our data in fairly basic way, a dashboard, which is very familiar. We actually use our data in here's a cool way that we actually use our data for as well. Because imagine in a company like the 30,000 users all over the world, and they're all interacting. This is happening when people just, oh, I need to ask Bill something, I'm going to send him an update request. Or I need to share a sheet with Danny. I'm just going to type his email, share the sheet with him, he can update it. So it's very self-directed. And here, the projector is really low res. I'm not sure why it's not showing it. One second. Nothing is showing on the screen. Let me refresh and see. So in this application, we're actually showing every single user and how they're interacting. So let it build up for now. It's rendering from the data set, about 2,900 users, 3,000, it'll start going up. Every dot is a user. Later I'll zoom in, you can take a look at it. And every line is a collaboration, either a share or a request update. And in this demo, still going a little bit, well, that is rendering. I'll let it finish. It is actually looking at all this collaboration and where people are working together and their titles, their departments, and clustering people on the fly. So it finished rendering 8,185 users. You can actually zoom in, and you can, it's kind of hard to do on a touchpad. You can actually zoom in and look at interactions. Now, really, when it's such a big group, it's kind of difficult, so you're zooming quite a bit. Sorry, I'm not doing well on the touchpad here. I'm waiting for it to catch up. You can actually click on a single person, look at what the person is doing, and actually over it, you can actually see their interactions and their sheets. So, this is the kind of data problem and data visualization we're trying to build into the product as a feature, right? So that gives you a kind of sense of what we do. Any questions so far on the product or what we do? Okay. So kind of two data uses, a typical one, which is the dashboard I showed you, and then something cooler, kind of what we call as a work map, how people collaborate. So about 3 months ago, we started on a POC to really assess, Kinesis, actually a set of AWS technologies plus Databricks to see how it can help us get to the next level. So, one of the first POC goals is it the right fit for our use, right? Because you hear all these cool things, a lot of people are using it, but for our use cases, does it make sense? Does it perform and scale to the levels that we need, right? One of the things that, as part of POC, was an important goal is that we want to build something right now, make the investment, but it needs to scale out. We want to make sure it scales out at least 5 times what kind of production peak rate we have today. So that's one important test. So it needs to be 5x. And then less than 5 minutes latency. 5 minutes was actually, we were hedging our bets because we did not know the technology at all. We really secretly wish that it has to be less than 1 minute. But we're very nervous to commit. And then the other thing we really want to know is, we can build all this technology. Is it going to be easy or complex to use and to maintain? Because at the end of the day, you got this great shiny new car, but if you can't really have your data science team draw and gather insights from it, it's no use. It's like having a great car, but you can't drive it to great destinations, right? So that was really important to us. Was it easy for the data science team to use? Was it easy for the ops team and the engineering team to develop on? And then the other question was, which came out of the ops team, was really, that's the elasticity, is it valuable, right? We really benefit from the elasticity. It's great, the concept is great, but will we actually grow things, expand it, and kind of expand it, and then will we ever bring it down, right? Because if elasticity is great as a concept, but you always had constant needs, and you just need 5 servers, probably it's cheaper just to buy the servers, right? And just use it for whatever, 4 or 5 years. So that was a big question, that we wondered as well. So those are the 4 things. Is it a good fit for use? What's the performance and scale? Is it easy to use? And would we benefit from the elasticity? So very quick on the timeline. So Bill and I started on this project. We spent 6 weeks kind of building it out, right? And trying different things. There were some lessons that we learned, which I'll share with you later. And then at the end of 6 weeks, we had something stable that scaled. And what we did then was we spent 3 weeks with the data science team where we actually test drove it, ran Tableau against it, did data science analysis against it, and say, hey, does this car help us get to places faster? So this is what we ended up with. I'm sorry, but the resolution is poor. I'm not sure if you can see that. Let me kind of maybe go through it real quick. Maybe there's a laser on this thing. Okay, and it works. So this box here is Kinesis. And what we use here on the left side, what we did was we didn't want to really instrument our production servers to send data into Kinesis for the POC. So what we did was we stood up EC2 instances with Logstash, and we wrote a custom, there was an open source plugin that we leveraged and then we extended. But basically, it is a Logstash plugin that sends the data from into Kinesis. So Logstash would monitor a folder, and we wrote some test scripts that generated a whole bunch of data, and then it would take that data and send it over to Kinesis. And then from Kinesis, it goes 2 different ways. One is Spark streaming, right? So we have a Spark cluster that ran Spark streaming. We also wrote a bit of code. Initially, we did a Lambda, then it became a Java KCL app. We'll talk about why that happened. But a component that basically took all this data from the streams and wrote it into S3 buckets. Okay? And once it got into S3 buckets, it again diverged. We took the data and took it, and we had a Lambda function that actually ingested the data into Redshift, and then we ran Tableau and SQL queries against it. Okay? So this path is really, once the data is here, it's more of a bit more of a traditional data warehouse, right? So data is structured, the schema, is on write. What we also did was, once the data get into here, when it landed here, it was JSON. So we would ingest the JSON file into Redshift. Then we also have a Spark cluster actually process the JSON into Parquet files. And then that's where we actually do our, the data science team did their analysis. We told the data science team, yes, you guys typically all use R and SQL here against, data store. We would like you to just use Spark against S3 as the data store and perform your analysis and tell us whether you like it. So that's, so it was, Parquet files for Spark here for kind of analysis. And then we had a workflow engine that basically coordinated. We use Spark also for the ETL and transformation. So data coming in here, straight copy, almost like a replication. And then on top of that, we want to do further aggregation and transformation of the data. We actually use Spark to do that as well. Any questions on this so far? Yes?
The data being sent from S3 to Redshift, the Lambda function there?
Yes. What's the question again?
How's the data being sent from S3 to Redshift?
Okay, so I'll repeat the question because I don't think the mic can pick up. So how is the data sent from S3 to Redshift? So this is a Lambda function. We basically set up this Lambda function to watch a S3 bucket, bucket and prefix or folder. And when data drops into there, the Lambda function would wake up, process that, and ingest it into Redshift.
And you're talking to
it's a copy command. Yeah, copy command. So the Lambda function actually calls a copy command. So, okay. Yeah, and we started this component here. We started from a AWS Labs. If you look for Redshift loader, that's the one we started with. It's written in Node.js. We did some extensions, we did some enhancement to it, and we actually contributed back to the open source project. So you can actually go, download that and start using it as well. So that was very useful. We like open source.
Did you mention, does Spark have the ETL? Do you like the ETL with Spark?
Okay, the question was, did we like doing ETL with Spark? Yes, we do. I think the biggest benefit for us was, at least to what I can see, because I'm a technical geek, but I'm also a business guy. The important thing about it is you can actually, once you ramp up on, we use PySpark. Once you ramp up on PySpark, you can use it for streaming. We use it for ETL. We use it for data science work. So there's no pivoting. It's not, it used to be we would write R code, and then after that, once you're done, you go write SQL, and people were switching back and forth between different technologies, right? So here it was really, once you learn it, you can apply the same techniques and in the same comfortable environment. We use notebooks a lot. That was very useful. And to us, that was a really big benefit. So we actually trained the whole team on PySpark. So, and it's definitely more powerful than just plain SQL, right? And we really like using notebooks and then PySpark, where you get the power of SQL, because we use actually Spark SQL within Python quite a bit as well. So we have the best of both worlds. Any other questions?
Yes. Which is this other data source on the left, down, lower left?
Here?
Yeah.
Oh, it says here, just notebook running on Chrome. So this is just, this is a browser running against, the Spark cluster. So, yeah.
Okay.
All right. Question in the back?
I'm curious, in your Spark, in the streaming that you were you doing any temporal processing? What kind of processing were you?
So, okay. So the question was, what's our processing do we do for stream? Our use case is when someone signs up for a trial on our software, they have a 30-day trial. We really want to know in real time, that they signed up, right? And also some preliminary information about them. Did they come from a Google ad? What were they searching for on the ad? And then what we try to do is then go like, oh, this person searched for online Gantt, online project management, or how to play checkers with Smartsheet, whatever those keywords are. And then what we do is that we do marketing campaign enrollment in real time, in near real time, right? We come in and say, oh, look at all these keywords that they searched for. This is what they are basically interested in. We'll enroll them into the right marketing campaign so that we have an email drip that goes out to them and talk to them in the language that they're interested, that makes sense to them. Just because of very diverse use of our product. So, so we don't really do windowed operations. So, all right, I'll keep going. So here are our learnings. So as I mentioned, it's not really showing up here on the screen. There's a line here. It says 7,000 records per second, events per second. There's a line here, 35,000. So this is our current peak load, right? We're looking at a system right now. We say, hey, when we build this system, it needs to at least support the current production load. And what we want it to do is also, obviously, when we build it, we want to use it for at least a few years to be able to support 5 times our current load. So 7,000 events per second, 5 times that, 35,000. So this is just our POC. When we ran it for the first time, I'm not sure why the axis is not showing up. Sorry, I apologize for that. It's just really blurry. This was like 200 events per second on our first run. And we were like, oh, crap. This is not going well, right? So, but this is very basic, single shard. I think we had, 2 shards. One log stash machine, just very basic, non-scaled out, single instances all the way through. And we were just trying to get everything to flow, right? Data, you drop it in Logstash, it shows up at the other end in Redshift and also for Spark. Then we had a bug, we fixed that. But this really shows how we scaled it. And the 2 red points are the only places where we made code changes. Everything else, this one here, we went from 4 shards to 8 shards. And then what we find that the Logstash instances was not generating enough test data. So we went from 2 to 3 instances. Then we grew our Kinesis batch from 1,000 batch size to 2,000. So really, and I'll skip this one for now, I'll come back to it. Then we went to a larger data set, a larger KCL EC2 instance, and then we went to 5 KCLs, right? And why we're showing this is, and this was really good for management, we were showing that when we needed to scale, it is not about writing more code. It is about scaling the hardware, right? Which is what we want, right? Not having to rebuild the system to scale. So this one was just a bug that we fixed. Here, what we found was, back in this diagram, I'll show you really quick. We initially wrote this as a Lambda function. And Lambda is really good. We used the Lambda here, worked really well. Over here, did not work so well. Because Lambda, it's who's familiar with Lambda? Can you show of hands of what it does? Okay, so it's a great AWS product that you basically just write a function, right? And say, and execute this function when something in S3 or Kinesis happens. And you don't even have to provision an EC2 instance or anything like that. So when the event happens, the Lambda function get executed and get passed the data. So it really is, you write this function, today you get executed 100 times, right? And then tomorrow you get a feature on Opera, and you get executed 1,000,000 times tomorrow, it just automatically scales, right? It would just execute 1,000,000 times instead of 100 times. So that worked really well here, because we would just drop files here, and then you get processed and ingested. Here, we needed more control. Because one of the things we found that when we want to ingest data into Redshift, we want bigger files, right? Redshift, like if you give it a 1 gig JSON file and ask it to ingest, it was ingesting it in like 10, 12 seconds, really, really fast. But if you tell it, here's the same 1,000,000 records, but I'm going to give you 5,000 records at a time and give you 10,000 files or something like that, it causes a lot of issues. So because of that, we had a requirement where we want to control and not just have a Lambda function, whenever it sees one thing appear, go process it. We wanted to collect them up, and then when it reach a certain threshold in terms of size or time, write one big JSON file so you get ingested. So that's why we went from, the Lambda function didn't work so well for us, then we used the KCL and wrote a Java application to process it. So that really was how we got from here, well, where is it? Sorry, from here. Once we did that, we passed our threshold, and then we got all the way up to here. This hit point here was 42,000 events per second. So if we did that every second of the day, there's like 100 billion events, which we're not going to get to. But we always have to code to the peak, right? Because your traffic and your loads are uneven throughout the day. So, any questions on this? Okay. So then, back to the question, would the elasticity benefit us? So really quick here, these 3 areas in green boxes, we found that it actually benefits us, being elastic, right? Kinesis, you set up the stream, you can actually set it up to auto scale. Well, auto scale in the sense that we were looking at using similar to what the utility that was described earlier, where you can split the shards and merge the shards as needed, right? S3, obviously, whether you go put in 1 file or 1,000 files, it handled the load really well. Also on the Lambda function, it auto scaled really well. So those 3 areas work really well. We really benefit from elasticity. This one here in the yellow box is good. It's not fully auto scale, but we were spinning up Spark clusters to process data as we need to, and the data scientists were using it. At the end of the day, we were shutting down the clusters. In the morning, we'll start it back up, use it. And there was one day where 2 data scientists were like, they were doing really large processing, and they kind of stumbling over each other. So then the second person spun up another cluster and used it for a few hours, then they shut it down. So the ephemeral use is really beneficial, right? Financially and also for productivity. And places where I put it in red, meaning that they're persistent resources. So the Java app running, KCL app that's running on EC2. That's something you need to set up. You won't shut it down every day, and you have to think about scaling there. The Spark cluster that we use for Spark streaming, right? It needs to be persistent to process the stream. And Redshift, obviously, the warehouse. You put data into there, you're not going to shut it down. So we found that at least in those 3 of this topology, these 4 locations we benefit greatly. Okay.
Quick one. So,
Yes.
just outside your POC, maybe we're going to get to that. Do you still use Logstash as the buffer between your application and the environment, or have you now moved that out now that you're outside?
Okay. So the question was, do we still plan to use Logstash as the way to ship data from our production environment into the AWS environment? We don't know yet. So we started our production project about 3 weeks ago, 2.5 weeks ago, and the data engineers are working through that. They're looking at tungsten replication. They're looking at Logstash. So there are a few other things.
Just one quick one on that. So is the data coming from something that's local in Amazon, or actually are you doing something a bit more fancy? Is it actually having to traverse?
Okay. So the question was, where is our data?
Yeah.
So our data is actually co-located in Rackspace, so in MySQL, and it is kind of not on-prem, but kind of co-located cloud. So yeah, so it's not at AWS, and it's 2 kinds of data. Data is actually coming from MySQL that's replicated, and then clickstream data, from logs. Okay, question?
How are you planning to monitor this whole work? Do you have any recommendations in terms of best practices?
So I actually will talk a little bit about that. In the POC, we did not get to it, but one of our requirements in the production system, it needs, we need a common logging and a common monitoring framework, right? Because if you think about it, this is one place where we were writing Ruby, Java, Node.js, SQL, PySpark, and not only are you coding in all these different languages, all these systems should log. You should be able to go to a single place and see where the errors are, right? And not have to go to like 6, 7, 8 different places. So we're actively looking into that. We did look at CloudWatch, but we didn't have enough expertise to ascertain whether we can customize it to actually write from all these different systems. So, question? Was there a question here? Okay. So. All right.
Yeah.
Yes.
Sorry, I remember the question now. So can you write a Lambda function to do the writing in S3 here instead of this?
So the question was, can you use Lambda to write data into S3?
Yeah.
Like this?
Yeah.
It was. We actually started with a Lambda function first. And we wrote a Lambda function here that monitored as data came into the Kinesis stream and write it here. But we needed finer grain control, because what we wanted was, we found that Redshift worked best when we send it large file, like I mentioned. So we needed to accumulate data here. And Lambda, in terms of quick reaction process, every time there's a piece of data in, it comes in, it's not a good model for us in that case.
60 seconds.
Okay.
I have 2 questions.
Yes.
The clusters you are using, are those Databricks cluster or EMR cluster with?
Okay. So in our POC, we did both. We first started with EMR clusters, testing it out. We actually started 2 weeks before they supported Spark. Right about the time they announced that you can actually check a box and provision Spark. So we then transit to that. We tried that. It worked okay. We wanted to get Zeppelin working on it, and we struggled. The POC was pretty tight on resources. It was just Bill and I. So we spent half a day trying to get Zeppelin working on EMR, and we couldn't. That's probably our fault. So then we then say, OK, that's good enough. We got a good sense of it. We then move on and use Databricks. And Danny did not pay me to say this, no. But it was just a lot easier, right? We spun up Databricks. You have the notebooks. It was all working. So so we tried both.
And what is your how did you onboarded your data science team to use PySpark? And how many data science guy actually is there or are there? And how do you manage it? How do you manage them to use basically Spark cluster? So
Okay.
because we are facing the similar kind of, we have a similar kind of setup, but we are facing a lot of problem to first onboarding them and also like
Okay.
making them use it?
So just a quick summary of that question for the recording is, how do you onboard and train your BI team and your data scientists, and then how do you manage them using different clusters and so on and so forth? We in the POC we did not experience that. We just had one data scientist do it, but those questions came up because we also did twice a week training classes for 4 weeks for the rest of the BI team to give them exposure to it, and they asked the same question too. Hey, if 6 people are all using the same cluster, what happens when we all cache something and we run out of memory and we keep tripping over each other? So we don't have a good answer to that yet. Yeah. So I think that's something we will have to kind of figure out. But in that one day instance where they actually then 2 people wanted to use something that was quite big, the second person just spun up a cluster, right? And the UI is easy enough to spin up. So we spent the money and did it, right? So, all right. So other learnings here. So real quick, we found that Kinesis scales well and very easy to use. Our ops people, when we started looking at this, we started talking about Kafka and Zookeeper, and they almost threw up, right? They were like, they really don't want to deal with Zookeeper. And, I trust their judgment. I'm not an DevOps person, but they were really resistant to that. So with Kinesis, I went to the console, gave it a name. It was very easy to set up a shard. The Lambda function, like I said, did not work well for us in this use case, so we rewrote it as a Java KCL app. Lambda worked well there. Redshift ingestion was super fast. The queries are fast too. I think tuning is very important. So I think as we go into production, there's a lot of lessons to be learned there on how to tune it, right?
What kind of tuning did you have to do?
So I think this is mentioned a lot in AWS Redshift talks. Kind of how the distribution key, the sort keys, how you set up the data. That's one thing. The other thing is, at the end, it's a columnar database, and it runs really fast. But still, there are cases where you want to use maybe what some people call more traditional data warehouse type concept to pre-aggregate data. I think there's still cases where there's still benefits to doing that in certain cases. Because our business users, when they run a report against it, it should be under 5 seconds, right? Unless it's a kind of a big visualization, okay, 10, 15 seconds max. So because of those requirements, if you just have straight, flat, kind of wide tables and non-aggregated data, and you want to get aggregations across large data set, it will still take time. So we figured in our analytics schema in Redshift, we did do aggregations still. So I think that's a part. The cluster size, SSD drives versus kind of regular drives. So I think those were the main things that came to mind. Okay. Spark is great for analysis and data processing. We liked it, like I answered before, because it was single environment. You learn the language, and then you can apply it in streaming, SQL, ad hoc analysis, ETL. You can write a notebook. Okay, so one of the big benefits is you can use a notebook and you do your analysis. So one of the rules we're starting to come up with is we say every report that starts its life as a notebook. So imagine the business person, they come in and they go like, hey, I'm interested in looking at this analysis. Initially, when they ask that question, they don't know whether there's goal behind it or not, right? They could ask the question, you look at the data, and there's no value to it. So we always do our analysis here, and then we work back and forth with the business, and they start looking at the data, and then they look at it, they ask us different questions, and this is a refinement process, an iteration right here in the notebook. And then once they get a certain point in time, they go, this is interesting, and I want to look at this every week on a daily basis. Then we actually would then use the same notebook. We'll clean it up, right? Because ad hoc analysis, you're putting in a lot of checks, counts, show schema, and so on and so forth. We would remove all that, and then schedule it as a job where it would actually process that data, put it in the S3 in the location that's monitored by the Lambda function, and that get ingested in here, and then we build a report here. So we're starting to say, hey, every report and kind of analysis begins its life here. we iterate till we like it, and I don't know, 40% of it never make it past here, right? It was like, we thought it was interesting, but we couldn't get anything from it. But some of them it's really good, and they say, hey, let's build the report, and then they would send it back to S3 in JSON, ingest it in here, build a report around it. So that was just something that we learned as a best practice.
Sorry, I might interject. So
yes.
You're not seeing utility in just taking a data frame slice right out of the Spark cluster and routing that into your BI tool, and you want to go back through, is there like another conditioning step in S3?
Okay, so that's a great question. The question was, let me know if I don't paraphrase it correctly. You're saying, why don't we just take the data frame and put it straight into Redshift? Is that what you were asking? So there is no, technically speaking, there's no way to take a data frame and put it into S3. S3 use a copy command, and you can ingest copy command from S3, DynamoDB. Maybe some people in this room can help me. There's like 3 or 4 other places, but you couldn't natively just take data from Spark, into Redshift. So there is a Spark package that someone wrote. It's open source. That basically within your notebook you can say save to Redshift with some options. Behind the scenes, it actually writes to S3 and then do a copy command. So. There's no magic, right? Because Redshift has only limited ways in which you can get data into it. So, okay. Let me see. Yeah, notebooks, the analysts and the data scientists really like it. Even the business users like it because it's one place. Before they would run SQL and then get in Excel and then do a chart maybe if it's kind of ad hoc for the business user. Here, they can write in the notebook, have the inline visualizations, and then share a read-only copy to the business, right?
Not use a Smartsheet to do that. They're not in a pushing to go, come on, put it somewhere in the Smartsheet.
That's too funny. So the question was, why wouldn't we use Smartsheet for it? We actually have a Tableau can run against Smartsheet as a data source. So we actually, we do some of that, but we use CloudWatch in the beginning to monitor the systems, and kind of going back to the original question. But it may not be a good fit. I'm not sure whether it was us not having enough time to ramp up on it, but it seems very basic in terms of what it can do. Maybe if we spend more time to learn about it and extend it, we could do more. But it seemed like it wasn't robust enough of a, I'll call it, data platform-wide monitoring system across all the different platforms. And we ran Tableau against Spark, and again, we had 6 weeks to do this, Bill and I, so quite a few things we had to pick our battles. We connected Tableau to Spark, and we tried to run some reports, and it was slow. Meaning it took longer than 10, 15 seconds, right? Which was kind of our threshold. So then what we did was we said, okay, let's not work on that right now. So we went back to Tableau running against Redshift. So.
Was that as ODBC, or how was that?
Yes, we ran it. The question was the test here via ODBC, we ran it against the, I think, Databricks thread, is it?
Yeah.
Databricks ships with a JDBC connector, right?
Right, it's a JDBC connection and thread, both.
Yeah, JDBC connector. So we used what came natively with Databricks. So, okay, so next. So, I think I talked about this already. We like Spark because it's an all-in-one tool. You can do ad hoc jobs, SQL, machine learning, streaming all in one. You don't have to switch back and forth. It's designed for scale and performance. One of the biggest issue we had in our previous system, we were running these big queries against MySQL. And MySQL is not the right tool, right? It's more of a OLTP database than an analysis database. And one of the worst things there is, it was taking sometimes an hour or 2 to run a query. And what is worse than that? Take the query running for 1 or 2 hours and then failing, right? Whereas what we saw here with Spark was it could take an hour or 2, but it completes, right? It doesn't time out, it doesn't, and so that was the timing out on the MySQL side was a big frustration for our team, for our analysis team, because they just blew 2 hours. Then they tweak something and try it again and cross their fingers and hope that in 2 hours it doesn't fail again. That's a terrible scenario. So supports many languages. The data scientists we had She participated in this. She was, she worked in R quite a bit, but it's interesting. She said, hey, I would like to use Python and PySpark. So she did all her work in Python and PySpark. And she was a fast learner. She learned it like in a week. Because a lot of the concepts are similar. So she just had to learn the syntax. So that was pretty cool. Notebook approach is great for analysis and documentation. But we had to retrain, as part of the training question, we had to retrain them to really, hey, make them think more about documentation, right? Writing your markdown, naming your sections and all that, writing pseudocode, and then coming in and writing, their PySpark code. So we kind of had to introduce concepts like that to make the notebooks a bit more readable. One of the other biggest thing we found was, hey, you can process all this data, do machine learning on it, cool. But really, 90% of the time was spent in data wrangling, exploring the data, pivoting the data, throwing out data that's bad, making the data nice and clean, reshaping it, and then the last 10% of the work was running clustering or whatever machine learning algorithm on it. That part was easy, right? Once you get the data in the right shape. So one of the biggest things that we found was it's really important if you want productivity and correctness, you really want to what we call build prefabricated data building blocks. So let me give you a good example. In our application, we track every single click a user does. Yeah, you click on a tab, you click on a grid, you open up the header, and if you want to share, like I sent an update to Bill earlier, there was 4 clicks, right? Click, 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 click. We track every single click. In fact, it was so granular, the product managers couldn't figure out. Because business users, what do they care about? How many shares did someone do? How many saves did someone do? They want a higher level metrics, right? And counts. So what we did was one of the prefabricated data blocks that we built was we actually took all this data and we remapped it to a higher level construct so that they can very easily say, show me all users that actually share sheet more than twice in a day, right? That's a lot easier than figuring out, okay, which clicks are those and which one, because they could click 3 times and hit cancel, right? So, what we found that this is kind of really important. If you want productivity, you want accuracy, you really need to build kind of prefabricated data blocks so that you can query against it easily. So now, some specifics on code. So in Kinesis, we started with the KCL, Kinesis Client Library. That helped us a lot, tremendously to get started. Bill actually did all the work here in the KCL. So this is his notes. He used Maven, pulling out the client library from AWS Labs. He actually then enhanced the code to support, because we knew we needed to scale. So in the Java code, he coded it in such a way where you can define what sort of data you are ingesting, so via configuration, and then also specifying, hey, for this KCL instance, what objects you are processing and from where. So that when we needed to scale, we were able to, in the previous chart, there was that growth chart where we went to 5 KCL. Going from 1 KCL client to 5 KCL client he just had to reconfigure everything without changing the code. So that worked out really well for us. So if we needed to go to 10 and we need to process 5 new data types, it just all can be done via configuration. So we found that when we started to scale out, that's why we went from 1 to 5. We found that the KCL instance, the Java instance running on EC2, was CPU and network throughput bound. So we went to, as we scale up higher and higher, we picked EC2 instances that had a lot of virtual cores and also was optimized for network throughput. At least for our case, those were the 2 things that was the biggest. Obviously with performance testing, you have to test based on your data and your flow. Other things may be bottlenecks, right? And for Spark, so here are some very specific things. I'm not sure whether it is too much detail. What we found was when we were loading JSON file in Spark, and if you do not specify the schema like this, if you just say, like here in this commanded line, you say read JSON, read the file from S3. If you have date time data in it, and you go print the schema, the date time field, the schema will come back as string, right? I think the implicit, if it tries to infer the schema, it doesn't seem to infer the schema correctly for date time. So what we did was we made sure that when we load JSON files, we actually specify the schema. So if the second field is a date time, this is how you specify it. And then in this second line here, after the read, you say schema, and you pass it the schema. And if you do your print schema, it will show up as a date time. That's kind of important, right? Because if in your where clause, you have between here and this date, if it's a string, it's not going to give you the right results. So that's something we learned. Next thing we learned was temp tables are global. So if you register a temp table and you call it my data table, and I'm working in one notebook, Bill is working on the same cluster in another notebook, he can actually select star from my data table, right? It's actually a global data set, which surprised us. We thought it was, just available in my notebook. So that can be good or evil, right? Like if I intended for it to be shared, it's great. If not, we had one instance where I just called something called customer data, created a data set, and started working with it. He would create another data set and register a temp table with exactly the same name. We were stomping over each other's work, right? So it can be good and evil. You have to be careful about that. So we had a rule, a convention that says if a data set is not meant to be global, right, which when you register temp tables tend not to be, we were telling everybody to prefix the name, prefix your first and last initial before whatever variable. So kind of create a kind of a namespace to prevent collisions. Repartitioning. So this here is some code where we were writing out Parquet files. So in part of a transformation, we're reading JSON files, then converting it to Parquet so we can use it in the Spark cluster. What we initially didn't know was we would just do this, mydata.write.parquet and the path, right? And then when we would go look in S3, even though let's say it's not a lot of data, it would write hundreds of files. And we're like, what's happening there, right? Because if you don't tell it to repartition, Spark is being like, I'm going to work as fast and as in parallel as possible. So basically, all the data that is distributed along the cluster, and probably Danny ran away, so he can't correct me. I'm not sure whether it's the threads or the task, they all write a single file each. So then that's why you end up with hundreds of files. Now, when you try to load it, obviously there's an overhead to loading hundreds or thousands of files, right? So if you want to optimize your load performance, like I'm saving this data set and then many people are using it, you probably want to call a repartition. And in this case, I put a 4 and then a write. And then in S3, you would see that in this case, it wrote out 4 files. If I pass repartition 1, then it will write out 1 file. So this will actually optimize your loads, right? Your subsequent loads, so it doesn't have to handle hundreds or thousands of files. That's something we learned. Parquet format, just at least in our case, we had a 100 gig JSON data set, and we converted it Parquet. It went to 3 gigabytes. It was pretty amazing, like the amount of compression we got. And obviously, with that, you get your load and querying performance is much faster, right? Because when your Spark cluster is reading, Databricks running in AWS still, right, reading from S3, there's still network, right, latency. So, the reduction in size is a big deal. And obviously, much cheaper to store 3 gigs rather than 100 gigs, right? And this is just within our POC. Imagine having 3 years worth of data, right? It really is. Parquet has worked really well for us. Partitioned tables. So this is an excerpt from the Databricks guide, and this is what we did. So I'm not going to go into much details, but the high-level summary is you can actually, in S3, as you store your data, let's say you have clickstream data, right? And clickstream data usually comes in by timestamp. And so you can actually organize in S3 by folders. Year equals 2015, and then underneath that you can go year, month equals 01, month 02, do that folder structure, and then you can do it down deeper into days as well. So then when you run a Spark query, it actually will be intelligent enough to say, oh, you're only looking for 2015, it will walk to that folder. Oh, you're looking for December, it will walk to that folder. And really, not only Parquet, because it's columnar at the root, it will actually benefit from that structure and get to the data quicker. So partition tables is the name of that feature. You can look into it as a feature. So now